story about the Fiberline Bridge started in 1995, when the owner of the Danish company Fiberline Composites, Mr. Henrik Thorning, came up with the idea of building one of the world's biggest composite bridges. The Danish engineering concern Ramboll, the American glass fiber producer Owens Corning, and the Norwegian polyester producer Jotun all supported the idea. They could see that it could give constructors and technicians all over the world an effective example of the huge potential in materials made from glass fiber reinforced polyester. The result was that the four companies, in cooperation with Kolding municipality in Denmark, financed and planned the world's first composite bridge to span a railway. The plan was to establish a 40-metre-long pedestrian and cycle bridge spanning the railway lines in the northern part of the town of Kolding. Production of the bridge started at Fiberline Composites in the spring of 1997. The many huge construction sections involved are produced using a pultrusion technique in which the polyester fiber reinforcement is, in a continuous process, shaped into the finished sections. This pultrusion technique ensures that the hardened polyester material obtains maximum fiber content and uniform quality. This, in turn, means that the finished structural sections have enormous strength and rigidity, a smooth, hermetically sealed surface, and are produced to precise dimensions with close tolerances. The production plant is fully automated, and a computer oversees the process at all times, thus ensuring that the temperature, the feeding of raw materials, and the process operation are all carried out ideally. There are some 18-metre-long sections in the overall construction of the Fiberline Bridge, and this means that the production halls are utilised fully, and a bit more besides. Despite their size and strength, the composite sections for the Fiberline Bridge are light in weight, a great advantage when they have to be worked on and handled. Each individual section has to correspond exactly to the drawings and construction plans. The strength of the composite material is decisive for the overall strength of the construction, and, for this reason, the sections are continuously tensile tested in Fiberline's laboratory. The tensile test proves that the strength of the sections completely meets the extremely high demands set for bridge construction. A considerable amount of material from each production cycle is checked by microscope. It is precisely the combination of polyester and glass fiber that creates the unique qualities of this material. Glass fiber composite has a tensile strength that is equivalent to steel. This, combined with a density that is about a quarter of that of steel, shows that this is a unique construction material that is also highly suitable for bridge building. A full-scale examination is included in the laboratory's comprehensive testing program, where the relative sections are tested in their final size. With the help of specially developed computer software, a section's rigidity and stress capacity under loading are examined in the test machine. Since Fiberline Composites was founded in 1979, thorough quality control at all levels has been an integrated part of the company's activities. As a consequence of this specific and documented work with quality, Fiberline Composites are certified in accordance with the ISO 9001 standard. Today, Fiberline Composites is one of the world's leading producers of composite sections, and the company has been responsible for a long series of development assignments that, at an international level, have contributed towards increasing the recognition of glass fiber reinforced polyester as a flexible, strong and durable construction material. The company has the largest range in the world, with over 6,000 different standard sections, and of these, 350 types are stock items. Fiberline Composites has an extensive network of distributors and subsidiaries throughout the whole of Europe. The Fiberline Composite story is a history of growth, a controlled growth, where insight and technology combine to produce a quality product. That's what you call know-how. The polyester is mixed according to Fiberline Composite's own formulas, resulting from many years' research and experience. This experience is also vital in the production cycle, where the properties of the finished sections are determined by the matrix and the amount and direction of the reinforcement. This makes it possible, therefore, to tailor-make a product to suit an individual client's requirements. For constructors, architects and engineers, knowledge about materials and their characteristics is vitally important. For this reason, Fiberline Composites has produced a complete design manual that gives answers to virtually every question concerning calculations for constructions in composite materials. The completed sections for the Fiberline Bridge are assembled in modules at the factory. The bridge is assembled by means of stainless steel bolts and adhesives. The Fiberline Bridge is designed with a bearing load of half a ton per square metre, in spite of the fact that the overall weight of the bridge itself is only about 10 tons. Because of the low weight of the composite material, erection and transport are carried out easily and without problems. This low weight is of tremendous importance in connection with the final construction of the 40-metre long bridge. The Fiberline Bridge is to be built where a great deal of the Danish north and southbound railway traffic passes through. This means that the building of the bridge has to take place during a few effective hours at night, a process that fully demonstrates the many advantages there are for big constructions in using plastic-based composite materials.
In a minute I can participate in opening this bridge. Thank you for your attention.
Not least for aesthetic reasons, the Fiberline Bridge will be a cable-stayed bridge, a construction that both visually and technically meets all expectations for strength and beauty. The Fiberline Bridge is one of the world's biggest bridges to be made from glass fibre reinforced polyester, and it will be a research object in the future, as frequent evaluations will reveal how the construction reacts to loading and to swings in the weather and temperature. The bridge is not affected by salt, water or frost, and Fiberline Composites expect it to stand for the next 50 years without maintenance, as a trademark for the many perspectives there are to be found in plastic-based composite materials. A strong, durable material produced from such basic substances as sand transformed into glass fibre, and wood that through millions of years has been transformed into oil and then, by refining, into polyester. A material that, in its molecular structure, is similar to amber, the Nordic gold that has been used for thousands of years for jewellery, in the form of a glass fibre and polyester composite material as an exclusive, long-lasting ornament in the neat landscape.